Okay, hi everyone. Today what we're going to do is we're going to start working on factoring. So let's first talk about what we did before, and then we're going to demonstrate what factoring is. So here's the general idea. Let's say what we did before, we say 3 times x plus 2. And we multiply the 3 by x and the 3 by 2. And you can see I'm sharing a 3 with everyone. You get a 3, and you get a 3. And that was pretty easy when it comes to just multiplying what we call a monomial. One thing by a binomial, two things. Now, if I say go backwards, right? Undo that. Oops, I messed up. Everyone start from step 1. Everyone go back. How do I undo this mess that I came up with here? And the way we do it is we say, okay, what was in common that you can see in the numbers 3 and 6? Using multiplication and division, what do you see in common? Well, I see a 3. Is there a 3 in 6? There is. Isn't that 3 times 2? So you can notice that we have a 3 and a 3 here. We have a 3 in the front and a 3 in the back. And we're going to factor the 3 out. Means we're going to undo that multiply. We're going to undo that multiply. And when we undo that multiply, we're going to end up with we're going to rewrite it as 3 in the front. And what's left over? Well, if we take out the 3, we only have an x. And if we take out this 3, we only have a 2. And we go back to where we started from. Okay. So let me do this again. Let's pick a different number. Let's use, like, say 10 and 2x plus 4, okay? 2x plus 4. Let's not use 2x. Let's use 3x plus 4, okay? So if I multiply it 10 times 3 and 10 times 4, we end up with 30x plus 40. Now if I made a mistake, that's go back. So factor, we're going to undo our multiplication. Undo multiplication. 30x plus 40. What number do you see that's in common between 30 and 40? Well, isn't 30 just 3 times 10? And 40 4 times 10? Okay, I'm trying to find the largest number I can take from both of them. And in this case, you'll see that I can take the 10. Okay. So let's do that. So I'll take out the 10 first, and we have left over a 3 and an x and a 4. And this is our general idea of factoring. We're trying to figure out what's in common. So if we can see what's in common, then we can definitely take out, factor it out by dividing it out, and then we'll see what we have left over. Oops. Okay, so our goal here is to, again, factor, undo what we're multiplying. Now, let me just give you some questions here. If I give you numbers like, let's say 7x squared and 14x, can you tell me what do these two terms have in common between 7x squared and 14x? You probably say that they both have a 7, and you're right, they both have a 7. And do they both have x squared? No, they both at least have one x, right? Isn't this x and x? So they both at least have one x. So let me highlight those, what we say we have in common. We have a 7, and we have at least one x in common. And that's what I want your brain to start triggering, to say, hey, I have stuff in common. So if I rewrite this as 7x squared, even if I write minus 14x, you'll see that they both have a 7 and an x in common. If I take out 7x, what do we have left over? We still have an x in the front and a 2 in the back left over. So we have an x in the back and a 2 in the back. Oh, sorry, minus 2. That was a minus 2. Okay. And you can, of course, double check this. 7x times x is 7x squared. And 7x times 2 is negative 14x. So this is how we're going to try to train our brain to look for what's in common that we can factor out. And this is like our journal way of just starting out. This is going to get more complicated, and we're going to be undoing a big mess. And we're going to try to find the possibilities that we can unmultiply stuff with. But to first start today, and to start our week, we're just going to start off with looking at how do I break up something that's kind of obvious already. Okay? So that's right, 4a plus 2a cubed. Okay, what can I factor? What can I pull out that we can say for sure both the front term and the back term have in common? 4 is 2 and 2, right? So we probably have a 2 in common. And then I'm going to write a bunch of a's here. A cubed is a, right? So don't they have at least one a in common? So let's go ahead and take out the 2a. See, they both have a 2a in common. If I take out 2a, what do we have left? Since we took out the a, we only have a 2 left in the front. And since we took out 1a, we still have 2 a's in the back. A squared. Let's double check it. 2 times 2 is 4. A. And then 2a times a squared is 2. And now I have 2 plus 1 is 3. And that takes us back to where we started from. Okay? And this is the easy way of factoring a monomial out. And we always want to try to do this first if possible. Let's give you guys, let's do another one. Let's do 16x to the 4th plus 4x cubed. Right? Now, what do you see that could be in common? Is there a 4 in both the front and the back? How many x's can we take that are in common? So if I do 16, isn't that 4 times 4 is 16? So wait, we do have a 4 in the front and back. And a bunch of 4 x's in common. 1, 2, 3, 4 in the front. 1, 2, 3 in the back. Well, at least 3 in each. So what's left over? If I take out the 4x cubed from everyone, since they have that in common, our greatest common factor, what do we have left? We have a 4 and an x in the front, and nothing in the back, right? We have nothing in the back, so we have to write a plus 1. So that's going to be our space holder. So essentially what we're doing, we're dividing. So this is a more complicated way of looking at it. I'm taking 16x to the 4th plus 4x cubed, and I'm dividing out a 4x cubed from each of these. I'm dividing a 4x cubed from each of these. And when I'm doing that, let's see what we end up with. With the 16 and the 4 divided out, and the 4 and the 3 divide out, we're left with 1 and a 4 left over. So 4x left over in the front, and this divides out to become 1. So we're left with 4x plus 1, right? So we bring them back together. We have a 4x cubed in the front and a leftover 4x plus 1 in the back. So does this apply to only 2 terms? And what if we have nothing in common? Sure, if we have nothing in common, if I write something like 5x cubed plus 2, is there anything common for 5x squared plus 2? No. So my answer is 5x cubed plus 2. And it's okay, sometimes we can factor stuff out and sometimes we don't, but we want to be okay to say, hey, there is nothing to factor, and that's okay. How about 23x squared plus 3? Can we say that these 3's are alike? No. 23 cannot be divided by 3. So even though they look like they have a number that would be similar, it's not done through multiplication. Right? So there's nothing I can factor out here, because factoring is just undoing multiplication. This is just 23 x cubed plus 3. Right. I can't divide by 3, right? See? This works, but this does not work. So you have to be able to divide it out. Because we're really undoing multiplication, and to undo multiplication, that's opposite multiply is divide. Let's get a little more fancy here. If I write x cubed plus 3x squared plus 9x. Okay? Looking here, what do you see in common? Does this 3 count as one of these 3's? No, that's an exponent for the x. But we can see that they all have an x. So we can take out what's in common. We have a common x. Now if I take out an x, how many x's do we have left? We have x squared plus 3x plus 9. See, I took out an x from everyone. And we have no more terms in common. Okay. And that's it.